Hello. Uh, am I audible, Shruti? Okay, so I'll just start the class. Uh, Apologies for the delay. This class was supposed to start at 5 earlier. Then I thought of shifting it from 6 p.m. So I guess I can wait for 5 more minutes and then we'll start our discussion. I'll wait until 6 and then I'll start discussion of this class. Okay, so shall we start the class? Shruti CS, Tapri Chaudhary. I think I can start the class. Okay, so in this class, we'll be discussing firstly, I'll be discussing the content that was given to you in week 5. And then we'll have a question answer session regarding the previous year assignment for the week 5 lectures. So, firstly, we'll start with unit process. So, basically, what is a unit process? It is a subdivision of the product system that assures a unique or a group of activity or operations. So, basically, unit process is the stepwise processes that are included during the manufacturing or during the life cycle of a assessment of a product. The whatever the steps that we go through, these are known as the unit processes. And basically, there are two types of flows or the processes that we understand. So, first flow is your intermediary or the economic flow. So this flow is used to link two unit processes. For example, first one is your, for example, during for your solid waste management. So once the waste gets into the facility, the first process is your waste segregation. So that is one unit process. After that, it may go undergo shredding or some other process. So shredding is your unit process too. So these are different unit processes, and the flow that links one or two multiple unit processes, that we are understanding basically the types of flows that are used to link those two or more unit process. So first we have intermediary or economic flow that is used to link two unit process, and uh, second we have elementary flows. So elementary flows are used to link the unit process with the environment. So this is a chart where we have unit process 1 and unit process 2. So intermediary flow is used to link 1 and 2. Unit process 1 and unit process 2. That we link both the process using intermediary flow. And how these processes are related to the environment, that we understand by the help of elementary flows. Then basically all the process during the life cycle assessment, all the process that are required to fulfill the function, that should be included. So all the inputs and the outputs should be included. Firstly, for example, during your life cycle assessment, the first phase is the preparation of the raw material. So for that we need resource acquisition. Then we go through the manufacturing phase. After that, distribution and transportation phase is there. Then we have use phase, and then we have end of life phase. So all the inputs that are involved in all these phases must be included. For example, during this natural resource extraction or the resource acquisition phase, the inputs can be iron ore, crude oil, water, wood, solar energy, or the land use. And the outputs of this phase can be the emissions in the air, water, and the soil. The air emissions would include carbon dioxide, sulfur dioxide, particulate matter, and VOCs. Then we have emissions in the water, that is phosphorus and nitrates, phosphates and nitrates. Then also some pesticides and metals can be discharged into the soil. And after that, other environmental interventions are also there, which occur due to the mining activities. These include your radiations, heat, and noise. And after that, we need to understand the complete life cycle of a material. So LC is if we want to perform a life cycle assessment in which we need to compare different manufacturing process for the same product, then and since the product being unchanged, so we need to we are since we are comparing the manufacturing process for the same product. So if the product is same, then the use and end of life stages will be the same in both the cases. So we would exclude these use phase, and this is your use phase, and this is your end of life. So what we are doing here is we are excluding both these phases. And then we are what we are concerned here with is your resource acquisition, that is raw material extraction phase, then your manufacturing and distribution phase. So this type of study is known as cradle to gate study, where we omit the use and end of life phases. Then and we are concerned only with the first, second, and third phase. Then this type of study is cradle to gate study. Next up, we have if we want to perform an LCA on the LCA on the municipal solid waste management. If you want to perform an LCA on the municipal waste management, just a second. Um, Arunima, if you may confirm that if my voice is audible to you guys.
Yes, ma'am, audible.
Okay, Shruti. Thank you. If in at any point if you're not understanding anything, then please let me know. And also apologies for the inconvenience because my system isn't working properly today. So I'll have to switch between my tab and the system. Okay, so we were discussing about the LC on the municipal waste management system. So for the municipal waste management system, this process corresponds to the end of life phase, where the life cycle of the product is over and its use phase is basically end. And now we need to dispose it off, or the some sort of we need to have uh, we need to have certain discussion about its how to dispose it or how to treat it, and how to deal with its end of life phase. Then this type of study that this will include the stages before the end of life. The This will exclude these stages before the end of life phase basically, since for the municipal solid waste management system, all these stages will be the same for same type of product. So we are only concerned here about the end of life phase, and this type of study is known as gate to grave, because after the use phase, what we this is your grave, right? So this was your cradle, and here we have gate. Basically gate we have at distribution phase, but somehow in some cases we also refer the use phase as gate. So this type of study will be called as gate to grave study. Now, defining the system boundaries. So basically, uh, to understand any life cycle assessment, or to perform any life cycle assessment study, we need to understand the system boundaries. So this was a an example. This is an example that is a about a study done in early 90s, which is used to compare a McDonald's and a conventional mom and pop restaurant. So basically, just a second. Yeah. So this was in a study that was used to compare the traditional McDonald's restaurant to a conventional mom and pop restaurant. So to compare two products, the boundary conditions or the uh, system boundary should be same for both the condition for both the studies. So for example, the agri-food production would be same in both the restaurants. The transportation that they're using is the same. Then for McDonald's, they are using disposable packaging, and for conventional restaurant, it is using it is cleaning reusable dishes. For example, the McDonald's only includes the cooking of the food, and uh, whereas in conventional restaurants, food preparation and cooking both processes are involved. Then the energy is used in cleaning, heating, and lighting of the restaurant, and same is in conventional restaurant. Different and the waste management that is involved in both the cases is first in McDonald's we have food and packaging waste management because lot of people tend to pack their products from the pack their food items from the McDonald's restaurant and they take it with them. So that is also one sort of packaging waste management is involved. And in a conventional restaurant, no such thing is there. So it only includes your food waste management. So in both the cases, the boundaries must cover the same type of reality, that is the same function or the service provided in both the cases. So, how do we define the system boundaries? To define the system boundaries, we are having three rules that we need to follow. So, first up, we have the compared systems must provide the same function. Both here, like for example, here both the systems are having same function, that is to provide food. So, the compared systems must provide the same function. The included processes are those which contribute more than a fixed percentage or the cutoff criteria of the total mass of the inputs to the system, of the total energy demand of the system, of the total emissions of an environmentally relevant substance. So basically, we need to include only those processes. We are concerned about including only those processes which contribute more than a fixed percentage in each and every unit process. We will include only those processes among all the unit processes involved. We will be including only those processes which are having a certain percentage or which are contributing a certain percentage of the whole system. Like in terms of the energy demand, we'll be concerned about and the identical stages or the process between the compared systems can be excluded only if this does not affect their functional equivalence. For example, in earlier studies like where we studied about the cradle to gate or gate to grave type of studies, so we could omit the we could exclude the earlier process only because removing them is not is not affecting their functional equivalence in both the cases. So these are the three rules to define the system boundaries, and among these the rule 1 and 3, these only apply to the comparative studies. 1 and 3 only is for comparative studies. Now, exclusion of the identical process. So, comparative LCA on two herbicides. Basically, this is an example where we need to perform a comparative LCA on two types of herbicides. Here, the functional unit what we have taken is producing 1 kilogram of wheat. So, the same functional unit will be applied in on both the herbicides. Here, we are using two types of herbicides, and the functional unit is production of the 1 kg of wheat. Now, if cultivation yield is the same in both the cases, if the cultivation yield is the amount that we are getting, if the cultivation yield is same in both the cases, then we can exclude the production and the application of the pesticides. Then the tillage, the process of tillage and the harvesting. Tillage is the process of the preparation of the soil before the sowing of the crops, and harvesting is after the crops are full grown. Then the process of cutting down of the crops to obtain the grains or the food products. This process is known as harvesting. So we are excluding the production and application of the pesticides, the tillage and the harvesting unit process, because the cultivation yield is the same now. But if the cultivation yield is different for each herbicide. For example, for herbicide A, if the cultivation yield is 4,000 kg of wheat per hectare, and for herbicide B, if the cultivation yield is 5,000 kg of wheat per hectare. So here we can clearly observe that the herbicide A, it needs 25% more land to produce the same amount of wheat. So, since the land use requirement is different in both the cases, now this will involve the use of no different use of pesticide, tillage, and harvesting. All the processes here will be different. So that is why we need to include all the unit process in this case. So that is how we decide how, like, if we want to include all the process, or if we can exclude any such process. We just need to ensure that if all the unit process are giving us same if all the unit processes are there, if the functional unit is same in both the cases, and if the cultivation yield is same, then we could have excluded the above said process. But since here the cultivation yield is not the same, then the process involved along with that, for example, your land use, the pesticide usage, the tillage, and the harvesting, these will have different inputs and the output conditions. So that is why we need to incorporate these in our LCA study. So now, coming towards the data requirements, like why do we need data during our LCA study? So basically, we need data to conduct an LCA study for to be able to evaluate the validity of the results, then to fulfill the goal of the study. So basically, in both the for both the process, we need to have a certain data. So these should take into account the quantitative and the qualitative aspects of the data and of the collection methods. So what is important here that firstly, the data quality requirement should be specified clearly, like what sort of data is needed for the study, and like what is the timeline that we are concerned here for, and what is the data quality, the source of the data, then what is the type of data that we are using, that it is measured data or calculated or the estimated data, then the nature of the data, that is it is a point estimate or the stochastic data or the data aggregation level. So this type of points should be very clearly mentioned uh, in our LCA study. Then the quality of data is very much important, and this includes certain factors such as the temporal coverage, that is the data that we are using should have the desired age and time coverage of the study that we are performing. Then the geographical coverage, that is for example, if you are conducting LCA, and LCA on the municipal solid waste management of this, for example, this Gazipur landfill area. So we need to have the data that must be collected from the geographical zone of that area, that is the local areas or the regional area of that around that specific landfill site. So this is your geographical coverage. Then technological coverage, that is we can have a certain combination of technologies, that is weighted average or the best available technology for the technological coverage of the data. The precision is the measure of the variability of the data, and completeness is the percentage of sites communicating the data. So our data should be precise and also it should be complete. Like it should include each and every site that is related to the study. Then we have two types of data sources. First is your primary data, and second up we have secondary data. So primary data is the data that we collect on our own, or the data that is directly concerned at the studied product. So this is the most useful data that we have. So it is specifically collected to do the LCA, and it directly concern the studied product at the manufacturer end, that is inputs and outputs of the required process, or the on the use profile of the product, or on the key parameters. So this is your primary data. Then we have secondary data. So this is secondary data. It is not specifically collected to do the LCA process. So basically, it is a the secondary data is basically the data. For example, data from a literature on a process, that is any theoretical explanation, or any empirical model, or any design criteria that we are having. So that is your secondary data, which is not directly used during our life cycle analysis part. And next example, we have average data on inputs and outputs of a unit process, that is found in LCI databases. So that is also your secondary database. Now, this is your life cycle inventory. Like, how do we formulate a life cycle inventory? So the product system has been defined, and it is made up of all the linked unit process for fulfilling the studied function. So these boxes here are showing your unit process, and these are your flows. Either, uh, if anyone may tell me what are the two different types of flows that we use to link the unit processes. Shruti, Papi Chaudhary, Payal, anyone? Like, earlier in this class only I've discussed two types of unit process to link the two types of elementary flows to link these unit process. So if anyone may tell me what are those flows. One was related to the flow to the one was used to link the unit process with the environment, and the other one was used to link two different unit processes. What was that? If anyone may remember, let me recall this. I will get into that slide, maybe then only you can understand. So first one is your intermediary or economic flow, and next up we have elementary flows. Remember? So your intermediary flow or the economic flow is used to link two different unit processes, and your elementary flow is used to link this unit process with the environment. So this type of flows, these are known as your intermediary flow. So for each process, the input and the outputs are must be quantified. So for each unit process, we need to have some elementary flows in and some elementary flows out. So all the inputs and the outputs, we need to have a quantitative uh, data about them. And after that, we are relating all the inputs and outputs of all the process to the functional unit, and then we aggregate them to find out the net input and the net output, and then only we can go for the interpretation phase. So that is your whole life cycle inventory formation. So this is a this is a flowchart for the lifecycle inventory procedure. So first up, we have goal and scope definitions. Then we need to have sort of preparations for the data collection process. Then we need to have our data collection. Then we go for validation of the data, whatever the data that we have collected, we need to have validate that data. Then relating data to unit process. Then relating data to the functional units, and after that, after relating all the data to the functional unit, we go for data aggregation, and then refining the system boundaries. And then after that, all the process, we have complete inventory of the life cycle analysis, or the life cycle inventory that we are creating. We, after all these processes, we get the complete life cycle inventory. So these two process, that is relating the data to the functional unit and the data aggregation, generally this is done by the LCA softwares. And after that, after if performing all this process, and if we get to know that there are some limitations involved in our LCA process, or if we need to have certain manipulations, then we need to refine the system boundaries. After that, we have a revised data collection sheet, and then we repeat all this process again if we have some additional data or unit process required. Now, it is practically impossible to quantify all the flows of all the processes. So that is why we had those system boundaries, and we included only those unit processes, or only those processes which have a significant percentage on the total LCA study. So the length of the supply chain is in theory infinite, and each economic activity is linked to almost all the others. So it is very difficult to quantify all the flows of the processes. So that is why we need to have LCI databases. So basically, here the data is available for each unit process, and the links between the process are explicit. So the inventory must be recalculated every time when we switch from one process to the other. This is done basically with the help of these softwares. So the type of databases that we have is disaggregated and disconnected process databases. So for the data available for each unit process, here we understand the input and the output uh, included with each of the unit process, and the links between the process have to be made by the user. So for example, the softwares, the databases that are studying this unit process as disaggregated and disconnected process, that we have USLCI, research centers internal databases. Then we have aggregated process databases. Here the data available at the product system level only. And for example, the black box that represent the cradle to gate inventory, or this type of databases are used in Gabi, ELCD, EcoInvent, or the S version, EcoInvent S version that we studied in the last class. Generally, we go for aggregated process database because it is very difficult to to have information about each and every unit process that is included in our study. So that is why we go for aggregated database. So these are the two types of databases. First is your disaggregated. Next up we have aggregated. So these are the some of the parameters in which we are comparing both the type of databases. First of user friendliness. So since the calculations are already done per system, so aggregated database is more user friendly, and whereas disaggregated database need softwares for calculation of the data. Then possibility to adapt to data sets. So in a disaggregated database, it is possible to adapt individual data sets, whereas no adaptation is possible in the aggregated database because it is based on the black box model. Then validity of the data. So it depends on the database, but can be checked in your disaggregated database. Whereas in aggregated database, it depends on the database, but cannot be checked. The contribution analysis is very high resolution. It is having high resolution, and the contribution analysis is possible in disaggregated uh, database. Whereas in aggregated database, the contribution analysis is possible, but the resolution is very low. It is on material level. And the possibility to create the distributed data sets is possible on disaggregated database, where it is not possible in aggregated database. So these are the available process database that we have. Some of the government agencies that are giving us process databases. Then there is also some software developers like Gabi, Sima Pro, and Umberto. So now coming towards the inventory data example. So this is some sort of inventory data that we have for incandescent light bulb. So now if we want to like formulate the CO2 inventory for the incandescent light bulb, so given like for the manufacturing and packaging process phase, glass was glass the requirement for glass is 22.8 per unit. Now we need to calculate the amount per functional unit. In terms of incandescent light bulb, we had 10 bulbs, 10 uh, light bulbs required per functional unit. So this would be multiplied by 22.8 should be multiplied by 10. This would be equals to 228. I'm calculating here for the glass. Now finding out the CO2 emissions per unit. So here we have CO2 emissions per unit of where is glass? This one. For 1 kg of glass, we have the CO2 emissions is as 0.52, right? For 1 kg of glass, we have this is 228 grams. For 1 kg of glass, we have CO2 emissions as 0.52. Now CO2 emissions per functional unit. These were CO2 emissions per unit. Now coming towards CO2 emissions per functional unit. This is your functional unit. So what we do here is 0.52, like 2 will be multiplying this by 228 into 0.52 divided by 1000. Why we divided this by 1000? Because this gram should be converted into kgs. So this comes out to be 228 into 0.52 divided by 1000. 0.118. That is kg per functional unit. So similarly, we can calculate for all the other factors and we can complete this table. Now coming towards the life cycle impact assessment. So all the elementary flows like as explained earlier, like all the inputs and the outputs have certain impact fall under certain impact categories, and then we can club together different impact categories to find out a single life cycle score. So this was the process that we need to perform. So for example, for the if we are concerned about the global warming, so we need to have some category indicators, and like This is the process of the impact 2002 plus. So this is a combined approach. In this, all the elementary flows are related to some of the midpoints of the impact categories, and different midpoints can be clubbed together to formulate different endpoints. For example, human toxicity, respiratory effects, ionizing radiations, ozone layer depletion, and photochemical oxidation. These can be clubbed together to formulate the effects on the human health. And after that, the aquatic ecotoxicity, terrestrial ecotoxicity, terrestrial acidification, land occupation, aquatic acidification, aquatic eutrophication, these all come under ecosystem quality, damage to ecosystem quality. These are the endpoint, different types of damage categories or the endpoints. Then global warming comes under the climate change, and non-renewable primary energy or the mineral extraction that comes into resource use. So these are the different endpoints. This is same graph that is giving to some framework for the different types of categories. Like these are the midpoint categories and these are the endpoint categories or the damages too. Like these midpoint categories create the damage to these factors. Similarly, the characterization here involves, like for the global warming, we need to have information about all the gases that cause global warming, and then we compare them to a single factor, that is CO2 equivalent, and we may sum this all and find out the total CO2 equivalent that is caused by all the by the emission of all these gases. So this is the characterization model that was for the global warming that was developed by the IPCC, and this was used to calculate the characterization factors. And this considers the infrared radiative force generated by a greenhouse gas emitted in the atmosphere over the different time horizons. And there are two parameters that are involved. First is atmospheric lifetime, and second is heat absorption. Now, coming towards the life cycle inventory analysis, so the choice of the LCIA method. So, based on your impact categories, we have some pre-established choices for the LCIA methods. Like we have also have certain category indicators and characterization models and factors which we can use for choosing the LCIA methods. After that, we need to classify the methods. Then characterization is there. Then we have normalization process where we normalize the LCI profile that is related to the functional unit, and we can use different reference systems for that. For example, the other product system, the geographic area for a specific year, or the per capita or information. Then we can perform some weighing and aggregation processes. These are the mandatory elements that are needed for the LCIA procedure: the selection of the impact categories, category indicators, and characterization models. After that, assignment of LCI results. This is in the classification phase, and in the characterization phase, we have calculation of the category indicator results. So these are the available LCI methods with the timeline. Like in 1984, we had volumes, critis, BOS methods. 1992, we had CML. Now, in the latest one we have in 2009, that is recipe. So these are the different types of available LCIA methods. Now, coming towards the LCA interpretation and ISO method, like that this is the method that is provided in the international standards IS code. And what are the key features of the interpretation phase here is the this is a systematic method to identify, qualify, and control evaluate, and the present conclusions based on the results of the life cycle inventory and or the LCIA phases in order to fulfill the goal of the study. This is a sort of iterative methods. Here we have three elements. First is an identification of the significant issues. Then we have evaluation considering completeness, consistency, and sensitivity checks. Then we have conclusions, limitations, and recommendations. So this is your interpretation procedure. Here, the first process is the identification of the significant issues. Second, we have evaluation. In evaluation phase, we have completeness check, consistency check, sensitivity check, and some other checks as well. Then the third process is conclusions, recommendations, and the limitations. And finally, we have a report of LCI a study. So, structuring results of LCI and LCIA in order to identify significant issues according to the GNS must account for the different methodological choices. First, we have hypothesis, then multifunctional process, excluded process, and impact assessment methods, etc. So, the we need to know that the ISO standard does not indicate what are the significant issues for a specific case. So, this is one limitation involved here. Then coming towards the evaluation phase, so here we establish and increase the confidence in studies conclusions. According to GNS, take into consideration the intended application of the study. Here we perform three types of checks: completeness, consistency, and sensitivity. According to the data quality assessment, how do we calculate completeness checks? We perform the completeness check to ensure that all relevant information and data needed were available and used. Then, for consistency check, we perform it to determine whether the assumptions, methods, and data were consistent with the GNS and were applied consistently throughout the study, especially for the comparative studies. So, for the sensitivity check, this is the uncertainty analysis to and assess the reliability of the final results and conclusions by determining how they are affected by uncertainties in the data and the various methodological choices made. Now this is a table that is showing your completeness check, like how summary of a completeness check is made. So these include different unit process. Then we have some options. Then is it complete or not complete? Then what is the action that is required if not complete? Then option B is there. And then again, we need to check if it is complete or not complete, and if it is not complete, then we again go for some action. We again have to specify the action required. So this sort of table is made to check for the completeness of the data. Now to check for the consistency of the data, same we have uh, different types of checks, that is check for the data source, then check for the data accuracy, data age, technology coverage, time related coverage, geographical coverage. Now then we have both options A and B, and then we need to compare option A and B and the action that we can take. This sort of table is used for consistency check. Now, the sources of uncertainty in the data. So, what are the different sources of uncertainty that are there with the data? So, first off, we have the natural variability of the measured parameters, that are the spatial and the temporal variations. Then, imprecision and measures during the data collection, that is random error or the systematic errors. Then, data gaps or the unrepresentativeness of the data, that is the time, geographical, and technical coverage. Then model uncertainties linked to choices, lack of scientific knowledge, and calculation of other errors. So this is your information about the week 5, the data that the all the content that was covered in the week 5 I have discussed with you all. Now coming towards the questions for the assignment for this week. So I'll be writing the questions. The first question is, I'll be writing the question and then giving you the options. The first question is flow, the flow connecting one unit process with another.
Ma'am, can you repeat this question?
Yeah, I'm writing this question. The flow connecting one unit process with another during
Uh,
LCA is known as. Acha, if I don't give you the options, if anyone may tell me the answer because I've discussed this twice during the class. The flow method, elementary flow that is used to connect one unit process with another. Shall I give you the examples? Elementary flow, inflow, outflow. What will be the answer? Anyone?
Elementary flow.
Yeah, right. Oh no, sorry. It's not elementary flow. I was confused. See, here we are concerned about connecting one unit process with the other. So this would be intermediary flow. Elementary
Yeah,
flow is used to connect the unit process with the environment, right?
yeah.
Okay, so the next question is that one only. The flow connecting unit process with the environment. So, what would it be during LCA? File. Now this would be your, see, I'll
Elementary
give
flow.
you, yeah, this would be your elementary flow. I just write all the examples. So this would be elementary flow, right? Now coming towards the next question, third question. What are the categories? I hope you all have got the material till week 4. I've uploaded all the videos and the PDF on the Google Drive. What are the categories of environmental impacts that should be considered during life cycle assessment? I'm writing options: resource use, economy, human health, ecological consequences. So the answer will be
First option, resource.
and it is a multiple option.
Oh,
What else we what else we consider during the LCA process? We are also concerned about the impact on human health, right? This was one of your endpoint during the life cycle inventory assessment, right?
yes, ma'am.
Then we are also concerned about the ecological consequences, right?
Yes, yes, yes.
So these three will be the categories that we consider during LCA. Now, next question. Which of the following is the writing clear to you guys? Like, are you able to understand?
Ma'am, I can't see presentation in my phone.
Okay, let me check it once because I'm sharing my screen. Okay, so for that,
Maybe.
I have shared my screen, but still I'll read the question once I
Yeah.
finish writing now, then I'll read the question for you guys.
Okay, ma'am. Okay, ma'am.
Which of the following should be considered for impact on ecosystem during life cycle impact assessment LCIA? Aquatic eutrophication, B, spiritual effects to these human toxicity and these aquatic acidification. So the question is, which of the following should be considered for impact on ecosystem during life cycle impact assessment? The options are aquatic eutrophication, respiratory effects, human toxicity, and aquatic acidification.
Aquatic acidification and aquatic eutrophication also.
Right. For the fifth question, we have what are the major checks suggested by ISO 14044 2006 during the evaluation step of interpretation procedure? So the question is, what are the major checks suggested by ISO 14044, that is your IS code for LCA, ISO 14044 2006 during the evaluation step of interpretation procedure? The first option is completeness. Second is your consistency. Next option is accuracy, and last is sensitivity.
Completeness, consistency, and
Yes.
last one,
Sensitivity.
sensitivity.
Sensitive.
Sensitivity.
Yes. Okay. So next up we have, out of the following, types of waste. Waste of equal amount, which two will generate more CO2, uh, landfill at the end of life. Options are inert waste, plastic waste, so the question is, out of the following types of waste of equal amount, which two will generate more CO2 in a landfill at the end of life? So the options are inert waste, plastic waste, municipal solid waste, cardboard waste. Which two will generate more CO2 in a landfill at the end of life? Inert waste, plastic, municipal solid waste, cardboard.
Cardboard
Which
and
two? And
and municipal waste.
uh, don't you think that plastic will generate more CO2 than your cardboard?
Municipal. Uh-huh. Yes. Yes, ma'am. Yes, ma'am.
So this would be your plastic and the municipal solid waste.
Okay. Okay.
Then for seventh question, we have the cutoff criteria during goal and scope definition of a LCA study is based on which the following: mass, energy, mass, economy. So the question is the cutoff criteria during goal and scope definition of an LCA study is based on which of the following? The options are mass, energy, environmental relevance, and economy. So this is a multiple answer question. So which would be the cutoff like factors on which the cutoff criteria is based? Options are mass, energy, environmental relevance, and economy. Answers? Anyone?
Economy.
Uh, do you think we perform the life cycle uh, assessment to find out the impact on economy? Like, is this can be the cutoff criteria,
Environmental relevance.
right? And see, for the goal and scope definition part, the cutoff criteria is based on the mass that is required, the energy, the input and the output flows that are involved in the process, and the environmental relevance. So the cutoff criteria is based on mass, energy, and environmental relevance, and it is not based on economy. So apart from economy, all three must be included in the cutoff criteria, right?
Okay, ma'am.
So for the eighth question, we have the major reasons for the development of LCA are rising waste problems and acknowledgement of limited resources in terms of energy as well as materials. So, this is a true false type of question. The statement is the major reasons for the development of LCA are rising waste problems and acknowledgement of limited resources in terms of energy as well as materials. So, is it true or false? Shall I repeat the statement? The major reasons for the development of LCA are rising waste problems and acknowledgement of limited resources in terms of energy as well as materials. So, this will be true or false? Anyone? So, this statement is questioning you about the development of LCA, like why this LCA methodology was developed, like why do we need to do LCA? And they are giving the reason as like the LCA was developed due to the rising waste problems and acknowledgement of limited resources in terms of energy as well as materials. So, is this true or false? Okay, so
True.
this will be, yeah, true, correct. Now, the ninth question is also a true false type of question. I'll quickly uh, write it down. The identical stages or the process between compared systems can be excluded only if this does not affect their functional equivalence. Okay, so this is also a true false type of question. The statement is the identical stages or the processes between compared systems can be excluded only if this does not affect their functional equivalence. So, is this true or false? the identical stages or processes between compared systems can be excluded only if this does not affect their functional equivalence. True or false? Shall I repeat the statement? The identical stages or the processes between compared systems can be excluded only if this does not affect their functional equivalence. So this would be true because that is the criteria for the exclusion or the omitting of any processes or the stages that they should not affect the functional equivalence of the system. So this would be true. Next up, we have if a manufacturer excludes use and end of life phase of a product then during the LCA, then it is known as cradle to grave LCA. If the end of life and use phase, the last two phases are excluded, then that LCA is known as cradle to grave or cradle to gate. What it is called?
Ma'am, can you repeat?
Okay, so if a manufacturer excludes use and end of life phase of a product during LCA, then it is known as cradle to grave LCA. Is this true
Get
or false?
false, ma'am. Get to grave, I think.
If the use and end of life phases are excluded, then it is known as cradle to gate, right?
Okay. Yeah, yeah, ma'am.
And if only the use and end of life phases are included, then it is known as gate to grave, right?
Yeah, ma'am.
Okay, so with this, we come to the end of this session. We have discussed all the assignment questions and the content that was required. So I guess that's all for today. Uh,
Ma'am, can you
shall I
repeat the first two questions?
first two questions? Yes, I
Yes,
would.
ma'am. Yes, ma'am.
Definitely, I will. Mm, okay. So the first question is the flow connecting one unit process with another during LCA is known as. Are you writing the question? Shall I dictate it slowly?
No, ma'am.
Okay. So the flow connecting one unit process with another during LCA is known as. First up, we have elementary flow, inflow, outflow, then intermediary flow. The correct answer will be intermediary flow. Intermediary flow is used to connect one unit process with the another. Shall I move to the next question?
Yes, ma'am.
Okay. So the second question is the same, just a minute change is there is that is the flow connecting unit process with the environment during the LCA. So if the unit process is being connected with the environment, then the flow is known as elementary flow, right? The options are same
Yes,
as
ma'am.
the earlier question, and the answer will be elementary flow.
Okay, ma'am. Thank you so much.
Okay, so shall I end this class?
Okay, ma'am.
Okay. See you guys next week. So I'll just
Thank you, ma'am.
end this class. Thank you so much. Thank you.
Thank you, ma'am.
Okay, thank you so much.